the IO app, I'm going to have an IO app simple, and in my run method, I'm just going to say lock and load for now. So IO print line, lock and load. Now, let me just save this. Hopefully, Metals is going to be helpful with me. Okay, lock and load seems to work. So in my server, so in the backend, the way that I structure applications is in so-called layers. Now, Zio has this concept of layers, but in Cat's Effect, we don't have this sort of concept, so we need some sort of discipline to organize these layers properly. And the layers that I'm going to show you here are a business logic layer, and I'm going to call this core. And the business logic layer contains anything that the application actually needs to do from the backend perspective, like validate credit cards, send emails, fetch things from the database, do some stuff based on the kind of interactions from the UI, and an HTTP layer to have some sort of external API from a user, from a UI, or from some external API that this application may support. So given that I just have an hour to write this application, I'm just going to focus on these two layers. And in the middle, you may have other layers to, I don't know, maybe produce, maybe interact with other applications or other components in your potentially giant business. Okay, so I'm going to focus on this business logic, and this business logic may contain interactions with the database, which is why here under source me scala-italy, I am going to build a little package, so new folder, I'm going to call this core, and here is going to be my business layer. Now, I'm going to show you the prototypical business layer module. So I'm going to have a little trait. Let's call this simple core module. And because we're going to use the Cat's Effect style, I'm going to import a bunch of stuff like cats and Cat's Effect. And here, this simple core module will be generally typed with a type parameter we generally call this f. This will have some sort of method, let's say do something or produce something or like simple functionality that takes some arguments, for example, whatever, an integer, and this produces generally an effect typed with something else. So a method that takes some arguments and produces an effect returning a value. And the way that this works is that this simple core module will be typed with an effect type that's generally going to be instantiated as IO in the application. So when you spin up the core modules, this will be IO, but not necessarily just for the polymorphic reasons. So this is not just to be super abstract and the type to instantiate it with IO at the end, but we use this so-called let's say low resolution terminology is this tagless final style, where by having this type parameter f with an actual implementation of the simple core module, you actually describe what it feels like or what it's like to create this sort of effect with some sort of capabilities modeled as type classes. So I'm going to have a live class. Let's call this simple core module live, or live simple core module with some constructor arguments. And this generally has type parameter f with a type class constraint, for example, an applicative or a monad from cats. It depends on what you want to do. And this extends the simple core module with f, and you generally override these simple methods. Like, for example, I'm going to say the meaning of life as quote, the meaning of life is, and I'm going to inject my arg plus 42, and then I'm going to say pure f. Now, pure is an extension method on the string, which means that I have to import cat syntax. And here, I'm going to have my f be an applicative because the pure is an applicative extension method. So depending on the kind of functionality that you want to expose, for example, to interact with the database or create some synchronous effects or return some, I don't know, maybe you have some multi-threaded something, the type class that is going to be enforced for the type parameter f is going to be different for your use case. For example, here I'm just going to construct a pure value, so I'm going to use an applicative. Obviously, we need some discipline for using Cat's Effect type classes, so you kind of have to know what the type classes are and what they do. So applicative is this type class, obviously, you know, that just creates pure values. Okay, so the simple core module. Now, I'm also going to expose in the companion object of simple core module live I'm also going to expose a method called, I'm going to call this make, which takes a type parameter f with the same kind of argument. So I'm going to have an applicative here with some argument as a, what is called? Let's say we have some sort of constructor argument as an integer or something. And this is an effectful smart constructor of this simple core module. So this is going to be an f of simple core module live f. And this is where you would instantiate all your resources. So you have some constructor arguments, and based on the constructor arguments, you instantiate something that is effectful. So you allocate resources, you spin up whatever, ports and sockets and memory and whatever. So I'm going to have my new simple core module live on this constructor argument, and then I'm going to have pure f because I don't really care about it. So this is the prototypical core module that I'm interested in this business logic layer. Hopefully, I have my simple core module live with a v. So let me add my little SPT here, and I'm going to have my project server, and I'm going to have compile because I want SPT to compile my stuff. All right. So any questions so far? All good? All right. So let me actually demonstrate this live with something that deals with a database. And for this particular talk, I created a little database with a little table called jobs with a bunch of realistic data structures. So for example, a jobs board will have job adverts for a company title, description of the job advert, the URL where you can apply, salaries, locations, and whatever. So I'm going to mimic this in a data structure. So I'm going to use some shenanigans here to create a domain model. So I'm going to have my new folder here, domain, and I'm going to have a little case class, and I'm going to have this thing called job with a, not with an S. I'm going to rename the file because I went a little ahead of myself. So this case class job will have this sort of thing. And in my DB SQL, I'm actually going to copy this entire thing. And I'm going to put the types as this goes. So this is going to be a UUID from Java util. Then we have a company text not null. So this is going to be a string. Then we're going to have a title. This is going to be a string. Description is going to be a string. External URL is going to be a string. Salary low integer, but this can be null. So I'm going to have an option int. Likewise, I'm going to have my salary high option int. Then we're going to have my currency text. This is going to be an option string. Remote is going to be a Boolean. All right. Location text not null. So this is going to be a string. And country, let's say the country is an option string. Okay, so this is my final case class job. Now, I'm going to also spin up my little database. I have a Docker Compose YML here so that I can spin up a local Postgres. So I am going to create a little terminal here. I'm going to have, let's say, Docker. And in my app, I'm going to do Docker Compose up. This, where is this? Not app, it's in DB. So I'm going to do Docker Compose up. All right, and then I can connect to this database. So I'm going to have Docker PS. This is going to be scala-italy 1. So Docker exec -it, this little thing, psql -U Docker, and connect to scala-italy, and select star from jobs. This is going to be my little table that I have already pre-built. So I have a bunch of entries here in the table. That's because in my initial DB SQL, I created the jobs myself. So I just created a bunch of dummy instructions here for Google, Rock the JVM, and whatnot. Now, my job here is to expose a core module that will give us the opportunity to surface out all the job instances, and also to be able to create or insert a new thing in the database. Obviously, the module can be arbitrarily complex, so I'm just going to demonstrate one. So I'm going to have in my core package, I'm going to create a little trait, and I'm going to follow the pattern that I described in my simple core module. So I'm going to call this jobs. The way that I generally name my module is mimicking the entities in my table. So I'm going to have my F here, and I'm going to expose two things like get all jobs. So this is going to be an F list string, not list string, but list job, and I need to import my domain. And also, I'm going to also create a job, and I'm going to expose an f of UUID just to return the ID of the job that was just created. Okay, so in order for me to do that, I need to do the application. So I'm going to have my little class, I'm going to have my live jobs with f. And most likely I will need a type bound here, but I'm going to attach that shortly. And what I'll need to do for a Doobie application is to have a Postgres transactor. So from a Doobie perspective, you know the library Doobie from type level? Okay, so I'm going to have my Postgres as a transactor. So transactor f. So this is going to be an extension of jobs. Okay, cool. So I'm going to override all of these. For now, I'm going to leave them unimplemented. Now, if I want to retrieve all the values in my database, I'm going to have a SQL interpolator from Doobie. The Doobie is quite adept at doing that. So I'm going to import a bunch of stuff. So I'm going to import Doobie. I'm going to import Doobie implicits and Doobie, I think, Postgres implicits. One disadvantage of using the type level stack is that generally, if you want to use a type level library like Doobie or HTTP4S, you kind of have to know the imports. Otherwise, the build tools aren't really all that smart in suggesting the right imports for you to use, so you kind of have to know them. But thankfully, there are not that many. So for example, in the Doobie case, with these 3 imports, you're pretty much done. You're pretty much set. You have access to interpolators and whatever. So in my interpolator, I'm going to have going to take all the items here. So I'm going to take all the fields, select these things, and I'm going to have from, the table is called jobs. And let me put commas here, because otherwise Postgres will be very unhappy with me with my query. So this is going to be a query of type job. And then I'm going to have a stream transact on the Postgres. And I think it's to list or something like that. I think this will not compile, but we'll see. Let's see the compilation. So this called backend compile. And thankfully, the compiler is quite adept at Doobie weak async target monad cancel throw. This is the kind of type bound that I'm going to have to add for live job. So this is going to be monad cancel throw. And I need to import this from cats effect. So I'm going to import cats effect star, and I'm also going to import cat syntax. This is kind of like a reflex import that I tend to write. Hopefully this will compile a little bit better. Well, it does. Value to list is not a member of FS2. Cat's foldable.
Compile to list?
Compile to list, yes. Nice. Okay. Let's see. Right, so now I need another type class, concurrent. Concurrent is stronger than monad cancel throw, so I'm going to have my concurrent here. So apparently this thing compiles. All right, so this is one simple way of retrieving all the jobs. And if I have my create, I'm going to have a SQL interpolator with going to have insert into jobs, and I'm going to add these. And I'm going to add all of them but the ID, because I want the database to create the ID automatically. If I show you the DB SQL, the description of the table generates the random UUID automatically. So I'm going to insert into jobs values. And again, I'm going to use a little shenanigan here. So job dot, and I'm going to have all these fields. This little thing. All right. So this is going to be an update. And then I'm going to have with unique generated keys of type UUID. And Doobie has encoders for the right type for the UUID. And this is going to be my ID column. And then transact on the Postgres. Hopefully that should do the trick. All right. So I have a little core module. I also have to create a smart constructor for it. So I'm going to have an object live jobs, and I'm going to have a def make with an f, which is concurrent. And this will have a Postgres, which is a transactor f. This is going to be an f live jobs f. And this is going to return a new live jobs f, live jobs with this Postgres, and then pure f. I don't have any other resources for this. Okay, now let me show how this layer works. So after I've built a little layer, I should be able to test it in isolation. So I'm going to have, in my application, I'm going to say make Postgres. And I'm going to run a for comprehension. This is going to return resources. Cats effect resources are super cool. By the way, here in your core module, besides a little effectful smart constructor, you can also expose a resource smart constructor. Let's call this resource f concurrent with Postgres transactor f. And this is going to be a little resource eval, say make Postgres. Resources are super nice in Cats effect, so I'm going to also use resources. Now for Postgres, I'm going to need a thread pool for the database, and then I'm going to expose the transactor. So I'm going to have my execution context plural. Fixed thread pool, let's say I'm going to give it 16 threads or something like that. And then I'm going to have my transactor as Hikari. Come on. I'm going to check my notes here. Hikari transactor. New Hikari transactor IO. And I'm going to have to post the details here. I know what's happening here, but it's because of for comprehension. Let's say yield transactor. And I need to be able to import this. We'll see. What's the import? Okay. I'm going, because imports break your code, right? So doobie transactor, doobie? Hikari, this little thing. All right, so I'm going to have to put the details here of the Postgres that I'm going to have to connect to. So I'm going to have my org PostgreSQL driver. Hopefully that's it. That's the thing. Then I'm going to have my URL so this JDBC PostgreSQL. My laptop's on fire. I don't know what's happening. PostgreSQL. This is going to be my local host, and I need to take a look at Docker Compose. This is at 5444, and this is scala-italy. This is going to be my database that I'm going to connect to. What else? Okay, I need the username and password. So Docker and Docker. These are my connection details. Don't use Docker and Docker in production, by the way. All right. So I'm going to have my transactor and also my execution context. This is my little thread pool. I'm going to expose the transactor. Okay. Now, let me build this make jobs as make. I'm going to run a for comprehension. Let's say Postgres in make Postgres and jobs in live jobs make Postgres. And this is going to be an IO here. Have my cats effect. I'm also going to import my core module. So com rock the JVM core. Metals has just failed on me. It's fine. I'm going to yield jobs. I can code in Notepad if I need to. So I'm going to have my make jobs on IO. Make jobs. That's it. Make jobs use, and then using the jobs module, I'm going to run a little program. So for yield unit, I'm going to show you something. So I'm going to show you how we can surface out all the jobs in the application. So I'm going to say, let's say list in jobs all. Then I'm going to have a print line for that. So I'm going to have IO print line, let's say jobs so far. And then I'm going to inject the list inside. Come on. Am I typing too fast for you? Restart. Okay, yield unit, and that should do the trick. Let's see. Now we're waiting for the compiler. Okay. What else? We have fixed thread pool, sync F. I'm going to have fixed thread pool. All right, you know what? I'm just going to type everything without you. Jobs all, okay. Something better. We have resource, longer explanation. Jobs make, not make, but resource, because I wanted to compose resources. Yes, right. And somewhere here we have the output. So in this application, we can surface out some data. So our first core module seems to work. Okay, now, after you've built a core module and after you build a second core module, it's our job to unify this business logic core layer. So I'm going to just group them together into a little data structure that I'm going to call core. So I'm going to have my little case class. I'm going to call this core. And this core will be typed with a type parameter f, which, by the way, is going to have the strongest type class of any core module. So this will have to be typed with, in my case, is going to have concurrent from cats effect. So let's import cats effect everything. So I'm going to have my case class core, which will have all your modules, so all your business modules here. In my top level rite of passage course, I have pretty much everything here. I have things that interact with the database. I have my email service. I have my Stripe backend checker or credit card checkout. I have everything here. So I'm going to have all your core modules. I'm going to say dummy module or simple module as my simple core module F, and then my jobs as jobs F. And that's it. This is a simple case class. I'm also going to have an object core, and I'm going to expose a method, an effectful thing like makeF with concurrent, and this will have the rest of the stuff like Postgres as a transactor F. So I'm going to have all the necessary constructor arguments to build the rest of the core modules. So I'm going to have four jobs as live jobs make Postgres, and simple module as simple core module live make. I think that was it. Do I have that? Yes, I do. Oh, I don't want to do that. And I'm going to yield a new core with core with jobs and simple module. I think it's swapped. So I'm going to have my simple module and jobs. Let's also swap these because I have a little OCD. Okay, so this is how you can unify all your core modules into a simple case class. You have make, let's say, this has the constructor argument, right? Obviously, it's 42. Value flat map is not, I need my cat syntax. Cat syntax, all star, come on. And because f is concurrent, obviously we have everything in monad and everything in flat map, and therefore the for comprehension seems to work. Okay, so have our first layer in the application. Nice. Let's do the next layer, which is the HTTP layer. So I'm going to have my new folder. This is going to be my HTTP, and I'm going to expose an HTTP API that will surface out all these jobs. Okay, so I'm going to have my little class. I'm going to have my job routes. So notice the naming pattern. So for surfacing out jobs in my application, I have the job data structure, I have the jobs core module, and I'm also going to have my job routes, which is an HTTP layer on top of that. Okay. Now, because in this case I'm working with HTTP4S, I'm going to import a bunch of stuff. So I'm going to import cats effect. I'm going to import also cats. This may be a little overkill, but I don't care. So I'm going to have cats syntax all star. I'm going to also import the HTTP4S stuff. So HTTP4S star and also implicits, HTTP4S implicits. Okay, let's, org. All right, I forgot the org. Right, org HTTP4S and whatever. Okay, job routes, obviously type of the type parameter F. Now, this thing will depend on something. So that I can access the things in my database, I'm gonna have to pass my job score module, jobs F. So I'm going to also import com ruck the JVM core, and this is going to be my jobs module, and I'm going to expose some routes. First of all, let me put a path prefix for this particular set of routes. I'm going to say private val prefix. That's going to be a string. This is, for example, at /jobs or something. This seems pretty sensible. And I'm going to have a private val, let's call this get all routes. This is going to be an HTTP routes F. Now, something that Antonio actually mentioned a couple of days ago is a little tip for bringing in the HTTP4S DSL. There are two ways of bringing the HTTP4S DSL into scope. One is to instantiate it here, like DSL as HTTP4S DSL F, and then import DSL star. But that's one option. Or you can also extend it here. So extend HTTP4S DSL F, so that I can have access to all the extension methods, all the pattern matches, and Antonio seems to agree in the back. Okay, awesome. So this is going to be my HTTP routes of. This is going to have a case for get at root. So I'm going to have like HTTP get at /jobs or /API/jobs. I'm going to surface out all the jobs in my little application. So I'm going to have my jobs all. This is going to be an F-list job. Now I'm going to flat map this. And because I'm going to have a, let's say, flat map, but I'm pretty sure this thing is going to be a little stronger now. We'll see. So jobs all flat map, and I'm going to have from the list, I'm going to have OK with the list. Now I have to serialize the list as a JSON or as some sort of string, so I'm going to import some Cioci packages. Now I tend to forget the Cioci packages, which is why I'm going to take a look at my core. I'm going to cheat a little bit. OK, I'm going to import IO Cioci generic auto. Hopefully that should do the trick. Please compile. Okay, let's see. Note that implicits live jobs kernel resource. That's not it.
Maybe it's
It's monad. Okay, let's try. It's not here. Okay, monad. Let's try one more time. No, we need entity encoder. Yeah, I also need another import. IO Cioci. It's the imports, man. It's the, I'm telling you. So it's org HTTP4S Cioci this thing, hopefully. Yes. Right, so imports make and break your life. This is the kind of stuff that will hopefully inform the builder of build tools, so that this sort of thing doesn't have to require the developer's memory. Let's say a private val, let's call this create route as an HTTP4S HTTP routes F. This is going to be HTTP routes of F. I'm going to have my case post at root / create. So post at /API /job /create. This is going to be a little request. So this is request at this sort of thing. And I'm going to have to parse the request's body as a job so that I can then insert into the database. So I'm going to say request as job. Now, this is an extension method that's enabled by one of these imports. I can't remember exactly what that is, so you have to remember the imports by heart. I'm sorry about that. So request as job, and I'm going to flat map this. So I'm going to say flat map. And in case of the job, I'm going to have my jobs create job flat map, and given the UUID that this thing returns, so jobs create returns an FUUID, all right? And given the UUID, I'm going to return an OK with that. OK with UUID to string. Now, notice the flat maps, so I might as well create a for comprehension. So this is my job in rec as job, this whole thing. Then I'm going to have jobs create. This is my UUID in this thing. And then the response is OK with UUID to string. Come on, work with me here. Yield response. All right, kill the flat maps, keep the for comprehensions. I like this. Okay. Rec as job. Okay, not found type job. That's easy. I can import this. So, com rec the JVM domain, and I'm going to import everything. Let's also put the stuff where it belongs. I like to be nice and tidy. Hopefully that should do the trick. Okay, now, no given instance of monad throw. Okay. So notice how we can, or we need to raise the power of the type class that we're using here as necessary. Cioci entity encoding, now concurrent. All right. Monad throw, now concurrent. Concurrent seems powerful enough. Hopefully that should do the trick. Uh-oh. My SPT has crashed. Okay, screw that. Typing ain't not bad. Okay, so this is my HTTP routes. Now, I'm going to also expose the router. So I'm going to have val routes as a router. And the HTTP for a server router, I'm going to have a path prefix. So prefix is associated to a combination of these two. So I'm going to have my get all routes. And the way that we compose HTTP for S routes is with this little combinator. This is the semigroup K combinator. It's enabled by the syntax package, which I've imported from by Reflex. Hopefully, so now I understand why I did that. And then the create route. Okay. In the meantime, let's start this stuff. Okay, so I forgot to mention how the prototypical route looks like, but hopefully you get the idea. We can also unify all such routes in kind of like a core module, which is the equivalent of an HTTP API, which is why I'm also going to do that here. So in HTTP, I'm going to have my new scala file, HTTP. This is a little class or an object. Okay, HTTP API. Let me make it a class though, because I also want to type it with the type parameter f. Also concurrent. I know for a fact that this is a concurrent because I'm going to have to expose the routes from job routes and whatever other routes you may want to expose in your application. And this relies on the layer below it. So notice that I created a layer for the business logic, which interacts with the database, does stripe, checkout, whatever. And now on top of that, we expose an HTTP API. And so this top layer needs to have access to the bottom layer. So I'm going to have my core F as an argument here. So I'm going to import com rec the JVM core star. Now, I'm going to expose all my routes. So create all routes here. So I'm going to have a val. Let's call this job routes as new job routes f with core jobs. This is going to be a plain loadable instantiation here. I'm also going to expose an object HTTP API with an effectful make method, which is why you may want to make the constructors private if you want to keep just the effectful versions of that. And I'm going to have my val routes. This is going to be my main HTTP application. It's going to have a router with, let's say, /API with job routes, and then you can compose that to other routes that you may create. Now, concurrent. Concurrent, I need to import from cats effect, and my job routes. Okay. So I have the HTTP API. Now, the HTTP API, I'm also going to have a def make f with core f. This is an f which is concurrent. This is an HTTP API F. And I'm going to have a new HTTP API with core pure F, which means I'm going to import cats syntax all star. F concurrent. Oh, I forgot Scala syntax. Okay. Right. So with this HTTP API, I have the HTTP layer, then I have the core layer. I should be able to build those in my main application. So this is going to be my backend. So let's say make server. And I'm going to compose resources here. Let's also expose a resource, def resource, f concurrent, and this is going to be core f. And I'm going to have resource eval make core. All right. Cool. So the make server will now have a bunch of stuff. First of all, I'm going to have my transactor in make Postgres. I'm going to yield something. For now, I'm going to yield unit so that the type inferrer can help me here. So the transactor. Then I need the core module. So this is where you would stack up all the cores together. No, stack up all the layers together. So I'm going to have core resource. Do I have a resource yet? No, I don't. You know what? I'm actually going to copy this resource, and I'm going to have resource eval make Postgres. Right. So that's going to be my stuff. So core.resource transactor. And then the HTTP API is HTTP API that I'm going to have to import. Boom. HTTP API resource core. So notice how I'm stacking all the layers together. And then I need to build my server. Server. What? We'll see. Okay, so server is my Ember server builder. And then I'm going to have my default IO. And then I'm going to have, have host. I always forget the imports here. So hopefully I like import Comcast IP forest, something like this. This is my interpolator for host import. So host, this is going to be localhost, and then my host. This is interpolator. God damn it. Okay, and then my port as port quotes, I don't know, name a port, like 8099. Okay, host port, and then with HTTP app, I think it's HTTP API routes or not found, and then build. And brace yourselves for compiling errors. So value host and, oh, it's with host. I apologize. With port. Oh, everything's green. Never expected that. So I'm going to have my server. And here in my main application, I'm going to say make server use. And given the server, I'm going to produce, you know what? I'm not actually going to use the server. IO print line rock the JVM. This is my welcome message. I can also print some ASCII art, but I don't have the time to type that. And then I'm going to have my IO never so that the server stays alive. Okay. That's it. This is my backend application. So I have rock the JVM at 8099. Wow. All right. Don't clap just yet. So I'm going to say HTTP get localhost 8099/API/jobs. Where is that? /jobs. I have a get. Hopefully I should get like a list of JSONs. If I do, then you can clap. Yeah, so I have a list of JSONs. This I just broke my own record here. Cool. We have a backend application, ladies and gentlemen. Now I'm going to switch to the front end now because I want to be able to use this stuff on the front end. Now the front end is a little bit interesting. So I have my little app module here. In my app, I have a bunch of stuff that I created beforehand. It's not rocket science. Here's the thing. I have a package.json for a regular front-end application for which I'm going to spin up a little npm, so modules app, and then I'm going to say npm run start. npm run start runs this little script, which serves a little local server with index.html. Index.html is just a bunch of like meta things that I copied from my application. This is the relevant bit, the HTML body with a single div, which is called app, in which I'm going to inject the entire JavaScript that scala.js will compile, and the script, which is called app.js. This thing is what the server will load. Now, app.js is still a one-liner, which imports a module called rock.the.jvm app from wherever the scala.js compiles my JavaScript. So this is an indirection for the JavaScript that the scala.js will compile, and that will load into the app div. So the app div is the place where the magic happens. So this is where the magic happens. I felt the need to type that. Okay, so this is my index.html. Cool. Now, in my npm run start, if I serve this, apparently I have an app.js. I don't like that. But I'm going to build the scala.js anyway. So in my app, I'm going to start compiling some JavaScript. So in my app, I'm going to create my little folder, source main scala com rock.jvm, and I don't have the time to build like a full UI, so I'm going to simply create a little thing called application. So object application or app, because the application was the backend, so the server. Now, again, plain Scala file, very scary. Now, I'm going to use a UI library called Tyrian, so I'm going to run a bunch of imports. Just like other type-level libraries, Tyrian has just a bunch of, just like 2 or 3 imports with which you can build just about anything. So I'm going to say Tyrian everything. I'm also going to import Tyrian HTML with a capital H for whatever reason. And I'm going to also import Tyrian HTTP with a lower caps H for whatever reason. Okay, now, object app. Now, I'm going to describe how a Tyrian app works. So this extends Tyrian app with 2 type arguments. One is called message and one is called model. The model is kind of like a view model of what is going to be rendered on the page. So this is the data of the application. Messages are little pieces of data that get sent when the user interacts with the page. So for example, when you click a button, that emits a message, and that message will be intercepted by the Tyrian app to update the model. So this is like a purely functional model update thing, and based on the model, the page will re-render with some actual visual representation of the model. So I'm going to have a case class called model, and an enum for message, and I'm going to have a case for no-op. So no-op is going to be something that doesn't produce anything. And the Tyrian app needs to be, now this is the kind of stuff where I need to take a look at my notes. Hopefully I won't. This is a JS export top level, and the JS export top level will expose this object as a JavaScript module, and that needs to be exactly the same as this little name that I'm importing from JavaScript. So it has to be called rock.the.jvm app. Cool. Now, this Tyrian app has four methods that I have to override. One is called init with configuration flags, and this returns a tuple of the initial data structure of the application. For example, this thing has a button here and whatever, but not as a UI description, but as a data description. For now, I'm just going to return the model as a plain data structure, so in an instance of this case class. And notice that we have a little thing called command. Command typed with cats effect IO and this type message that I have here in my enum. This is the first command of the application. The command is, you can think of it as a wrapper of an IO that emits a message when it's done. And the message is something that will be emitted by the application and caught by the Tyrian app when the IO is finished. In this case, it may be an HTTP call when the application is being rendered for the first time. So I'm going to type it. This is going to be my first HTTP call. Hopefully, I'm going to use my backend that I wrote a couple minutes ago. So for now, I'm going to have cmd.none. So I'm not going to now I'm not going to emit anything. I'm going to override, it's called subscriptions. This is, for example, for time things. For example, when you want to refresh things based on time, like a social network or something with a feed of things, I'm going to have sub none for now. So this is a wrapper of an FS2 stream, which is quite interesting. If we have the time, I'm going to tell you at another talk. Then I'm going to have an update, which is a purely functional way of updating a model. Based on the message that the app intercepts, I'm going to return a new model and maybe a command that will be emitted and return a new message when it's done. So for example, when the user clicks a button, I'm going to intercept this message, and based on this message, I'm going to update saying loading, and then I'm going to emit a backend call, and when that thing is done, I'm going to update the app. Hopefully I'm not talking too fast, folks. I only have a limited amount of time to make this thing work, so I can't afford to drink water too much. Okay, so I'm going to have message as message match, and in case message no op, I'm not going to do anything, so I'm going to return the same model and CMD none. Okay. As I'm going to upgrade the message with new types, I'm going to also add them in the pattern match. I'm going to show that to you later. And then I'm going to simply override the last one, which is the view, which is the UI representation of this model. For example, I'm going to have div with plain HTML app. Okay, let me compile this. So I'm going to spin up a new SBT. Sadly, this takes a bit of time. Water for me. You loaded too fast. Project app, and then fast opt.js. This is the equivalent of compile for frontend. How fast can I drink water? Ha, gotcha. Cool. Now, as the application has compiled, my node is going to refresh my page. So notice that at localhost 1234, I have plain HTML app. This renders the initial thing. Okay, cool. Now, when the application loads, you can emit your first command. Now, this is going to be a little backend call to my backend app. So the backend is still running. So notice that we still have rock the JVM here, as this can receive backend calls. And I'm going to emit my first backend call. So I'm going to have an object. I'm going to have my backend client. And I'm going to have a function called, let's say, fetch jobs. And this is going to be an HTTP call. Now, the Tyrian API for HTTP is very, very low level. So you specify an HTTP request with HTTP method, with payloads and whatever. You can abstract this away into functions that are slightly more, let's say, ergonomic, but I'm going to use the low-level API. So I'm going to say HTTP, send, and then I'm going to have request get at the URL is going to be HTTP localhost 80, what was that? 8099, the port was 8099. Okay, 8099/API/jobs. That was it. And then I'm going to have so request get, and then I'm going to have a body with the no, I don't need a body. It's just a get. Okay, so HTTP send with request get, and I'm also need to be able to decode the response. Now, in order for me to decode the response, notice that we have a decoder, which is a plain wrapper over two functions, like string to message and message to string. So I'm going to have decoder. Okay, you know what? I'm going to have my decoder of type MSG. And this thing has an apply method. I think it has, look at that. So we have an apply, which takes two functions, response to MSG and HTTP error to MSG. So I'm going to have my response. And here is where I need to parse the list of jobs. And let's say MSG no op. And then you need to parse the error. So I'm going to have, for example, a case for error, let's say message string, and a case for loaded as a list list or jobs as list of job. What? I don't have job here in my application, in my front-end app. So, say cmd none for now. Let's comment out the backend client because I don't want to get into trouble. But notice that we now need to be able to access the job data structure from the backend. The problem is that I don't have it. So I'm going to do a very, very scary move, but hopefully that won't break the IDE too much, which is the fact that I'm going to copy my domain to the common package. So in shared, I'm going to have my new folder, it's source main scala com-ruck the JVM. And now I can simply copy the code from my backend to the core module, to the common package, and that was going to share the Scala code between the front end and the back end. I'm going to be done in a moment. So I'm going to simply take the domain, paste it here, hit the move, and watch hell break loose. Sorry about that. So that just broke everything. Dismiss. Okay, so I'm going to have my project server. Let's say compile. And let's see the kind of errors here. You know what? Get out. Okay, so com-ruck the JVM domain. I think SBT is going to compile my code. Look at that. So SBT is fine. Metals, not so much. Let me restart the build server. Hopefully that should do the trick. We'll see. But SBT is the source of truth. I don't care. Oh, look at that. Everything's green now. Oh, no, it's not. Okay, we'll see. But SBT is my source of truth. I don't care. Stop showing. I don't want to see this. So in my app.scala, I need to be able to now import domain. This is a very, very big thing because now the frontend has access to my code. So my fast.js, where is that? Java. This is my frontend compile. And my scala.js can now compile with this new domain model. This is great. I can now use my job. And I can do my job. So let me do the backend call. So I'm going to have to parse the response and case loaded with a capital L, because otherwise people here in the room are going to kill me. So let me have my error as MSG error with error. I think it's message or something, error to string, I don't care. Parse the error. Now, here is where I'm going to have to parse the response's body, and I'm going to have my Cioci packages, which I tend to forget. So let me import the Cioci parsers. Import io Cioci generic auto. I'm going to import io Cioci parser, and maybe syntax. Okay. Io Cioci syntax. Okay. I'll do whatever you want. Okay. So response. Now response body. I need to parse that. So parse response body. This is going to be a plain string. This is going to be a flat map underscore as a list job. So the H cursor that Cioci returns to me is going to be a list job. And then I'm going to match, you know what? Oh, that's fine. That's fine. This is going to be an either, I think. So, okay. Case left with a parsing error. I'm going to have a MSG error, let's say parsing error, and then E. Hopefully that should do the trick. And hopefully on the happy path, if we get a right with list, I'm going to return an MSG loaded with my list of jobs. That's it. And the comma so that the compiler can compile my code. And don't tell me that it actually compiled. Okay, cats kernel async. This is going to be fetch jobs command of IO and MSG. Hopefully the type. Ha! That did it. Okay, let's go. So instead of cmd none, I'm going to have my backend client fetch jobs. This is going to be my first command. Right. Let's see if this thing compiled. It compiled. It served the app. Come on. Refresh my content page. Oh, my backend isn't running. Application. Let me run this one. Rock the JVM. Course policy. I forget. Course policy. So I'm going to have my cores. Let me kill this. Run again. What? Address already in use. Oh, really now? Oh, really? Okay. But the port is still not helping me. So let me try again. Oh, it did. Come on. Give me my jobs. Has been blocked by course. Are you sure, Antonio? Are you sure you're not leading me astray? Let me try. Guys, I'm going to be done in like 2 minutes. If this thing works, then it appears Antonio is right. You know what? No, I'm wrapping the cores myself. No, I mean the core starts with a plain. You know what? I'm going to start with a 8098, and here is 8098. Because obviously, if one port doesn't work, okay. Backend compiles.
You missed the 8. You missed the app.scala.
What?
You missed the 8 here.
Ah, damn it. All right. Apparently, it's still on 8099. Okay, if it's 8099, I'm going to take that. No, you know what? I think I think I know what's going on here. I think Metals is running an old version of the app. Otherwise, I'm just gonna hit it from SBT. So I'm gonna try it one more time from Metals. Otherwise, I'm gonna just run from SBT. So 8099, 8099. Let me try the application one more time. Come on, Bloop. So at this point, we're kind of done. Did you get the idea while this thing is compiling? Yeah?
We did.
Can you hear the fans? Not those fans, the fans in the laptop. Okay, you know what? I'm going to run it from SBT. So SBT, project server, and then run main com rock the JVM application. I prepared for this. Takes like 2 seconds. All right, 8099, com rock the JVM. Come on. You know what? I'm not doing this. I'm not rendering anything. I'm rendering plain HTML app, but, right? So I'm going to have a jobs model, jobs map, render job. And I'm going to have like a private def render job, job, job. This is going to be an HTML, like a div. Let's say job2string, because I don't have time for anything else. But otherwise, you can build like your entire thing. Come on. Model jobs. Model jobs is not a member. What?
Model is empty.
Okay, jobs, list, list job starting as empty list, and in my update, in case we get an MSG loaded with list, I'm going to return model copy with jobs as list and command none. Okay. Obviously, you can set up statuses and bootstrap things like whatever. You see this? This is the most beautiful app that I've ever built. Right, this is it. This is it, folks. This is like a full stack type level app. Hopefully, you got the idea as this thing went along. Maybe a question or something.
Yeah, someone has one question.
Yeah.
So, what do you think about using tagless final or using maybe just IO directly with the phone?
IO is great. So if you don't really care about this tagless final sort of thing, you can just use IO. IO is great. The reason why I'm using the tagless final style is so that I can get super clear on which effect does what. So the type classes describe the capabilities of the effects. That's it. I mean, for some people, I know the benefits are marginal, in which case you're fine to use IO. I just wanted to demonstrate like the entire thing, the entire experience. Yeah.
Are there any, sorry, in English. Are there any companies which use Thailand or build from Thailand?
Tyrion, this UI. Tyrion. Tyrion is a pretty new UI library, and it's still at 0.7 or something. I want to show this to you because it's super cool. I use it in my own course, it can help you build arbitrarily complex applications. I don't know any companies using it yet because it's so new. I just wanted to show this to you. Maybe you'll be interested in trying it. Yep. Yeah, it's the same. It's the same guy, Dave. Yeah.
Do you know other UI libraries that has a similar model like the one?
This thing, no. This is the only one with this model. The other, I'm pretty sure you've heard of Laminar. The Laminar is also great, but it uses a completely different model, the functional reactive programming model.
Is it inspired to Elm?
Yeah, Elm. Yeah, Elm was actually the inspiration for the Tyrion library. All right, folks. Thank you so much.